Okay, something happened to the audio, so I don't know what's going on. It's a little fuzzy, but I'm remaking this video, but I'll do my best. All right, so let's look at number 7. Basically, this is inversely related, meaning as one goes up, the other goes down. Usually when things are proportional, right, they start at 0, 0, and like the more crafts you make, the more money you spend. The more miles you walk, the more time it takes. Inversely is when one goes up, the other goes down. So like if you have one person doing a job versus 4 people helping, it should take less time, okay? So these are inversely, meaning as one goes up with multiplication, the other one's going to go down. And again, it's still always multiply and divide. It's just not multiply, multiply, or divide, divide. It's one's multiply, one's divide. All right, so I'm going to go down to one person, which means I'm going to divide by 3, which means it should take 3 times much, 3 times more time to get it done. So what is that? 5 halves times 3 over 1 is 15 halves hours. And I'm just going to leave it like that. And then I want to go to 2 people. So I'm going to scale it times 2, which again, that means this one divides by 2. Because again, if I have more people, it should take less time. And dividing by 2 is the same as multiplying by the reciprocal. So that should be what? 15/4. So that would be what? 3 3/4. Oops, I don't know why I wrote that. 3 3/4 hours. Okay. All right. So again, if it's inversely related where the more workers you have, the less time it takes, then if you divide one side, you multiply the other. If you multiply one side, you divide the other. All right. Let's look at number 6 on the next page. All right. So the jewelry store, there's a couple ways we can do it. One is we can just think of 100%. And we want 60% of it to be gone, which means 40% of it should be the cost of $79.95. And so what I could do is I could do algebra. 40% of the price is $79.95. I'm going to divide both sides by 0.4. And again, I'm okay if you use a calculator on this. So 79.95 divided by 0.4 is $199.88 about. Okay. Another way that might make more sense to do that is a strip diagram. So I'm going to cut it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total. 40% would be what? 4 strips, 1, 2, 3, 4. And I want those 4 strips to be the $79.95. So I could divide them each by 4 to figure out the value of each strip. So $79.95. And I'm not going to round it because it's money and we're going to do that. So this is the value of each strip. Because each strip is 10%. So if I divide that by 4. So then I'm going to multiply by 10 strips to total all that up, which would again be the same answer. So I'd round that to this. Okay, so you could just kind of visually think about the 40%. I could do a percent table and say, well, 40% is $79.95. Another 40% would be $79.95. And then I need a 20%, which would be half that. So I'm going to divide it by 2. So let me take that $79.95, divide by 2. And again, don't round to the end. So then all of these add up to 100%. So I'm going to add these up. So I'm going to add 79, and I'm just going to multiply by 2 since I have 2 of them. And I still get the same answer. So lots of ways of doing that one. All right, let's look at number 8. Okay, so 8, percents are kind of moving targets. So you got to think a little bit. So again, I'm going to do a strip diagram. And I'm going to do, let's see, it says Connie and Benton bought identical. Okay. Connie spent 25% less than Benton. Then did Benton spend? Okay, so we're comparing her to Benton. So I'm going to let Benton be, I'm going to use $100 because then the percents, like the $25 and the 25% go with 100%, same thing. All right, and Connie spent 25% less. So she only spent $75, which again is 75% compared to his 100%. All right. So it says, if not, explain why not. Okay. So did Benton spend 25% less than her? Well, her 25% would have to be cut in 4, so they're going to be different dollar amounts. So kind of how much, how much more did he spend compared to Connie? Well, if I'm comparing Connie to him, yeah, 25% less. But if I'm comparing him to Connie, then Connie is my whole. So these strips are my whole. So he spent one more strip compared to 3. And so he spent 33.3% more than what she did. If I did percent change, right, it's a $25 change, but I'm comparing it to, again, I'm comparing it to Connie. And that's a third, which again is 33%. Now, if I flip it around and it says Benton spent 25% more than Connie, did Connie spend less than him? Okay, so he spent more than Connie. So this time I'm going to let Connie initially be the 100. And again, 25, 25, 25, so that's 100. All right, and then he spent 25% less than, let's see, Benton spent 25% more than Connie. Okay, so here's Benton. So he's going to spend what she spent, but then now he's spending what, another 25% more. So again, she's the 100% or $100, so he would be 125. Okay, so then the question is, let's see, if not, tell what percent less than Benton and Connie spent. Okay. So Connie spent one square or one strip smaller than, and again, we're comparing him to be the whole. So she spent one strip out of 5, and I could scale that by 2 and get 2 out of 10 or 20%. Okay, so she spent 25% less than him. If I did percent change and I compare 125 and 100, it's $25 less. But again, I'm comparing her to Benton. So that would be 125. Which again, I can divide and get 1/5, which again is 20%. So percents can kind of be moving targets a little bit. So you got to be a little bit careful. All right, let's look at 13. And I'm sorry if this is buzzing, but this is the second time I made the video. The first time I had no sound. All right, so I could do 100% for one, and then the other one is 100%. So the larger one is 12% larger. All right, so there's my 2 strips. And it tells me that that 12% is worth what? That is 3 more ounces. So the small box has 100%. The other box has 100% plus 12. So I know that 12% extra correlates to that 3 ounces. All right, and I want to get a friendly number. So remember, friendly numbers with 100%, right, are like 10%, 25%, 20%. Anything that goes in there. So are you okay? 4 goes in there. 5 goes in there. So I can get a 4 with these numbers because if I divide both by 3, I can get a number I can work with. And then at this point, you could just scale it by 25 to get 100. So 100% would be 25 ounces. So that would be the smaller box. And then if I add 25 plus 3, the larger box is going to be 28 ounces. Okay. I suppose at this point, if you wanted to, you could divide by 12 and get 1%. And then 3 divided by 12 is either 1/4 of an ounce or 0.25 ounces. And then you could scale by 100 at that point and get 100%, and scale by 100, probably with the decimals easier, and get 25 ounces. So that's up to you. And then from there. So again, percent table, strip kind of helps you think about it. Okay, let's look at 15. Again, strip diagrams are our friends here. So we have a box of candy, so I'm going to cut it. And again, we have nice percents that go with 10. So 9 cuts. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have what? 60% is what flavor? 40% are dark chocolate. So there's my 40%. And then the 60% is milk chocolate. And so notice that the difference is this, extra 20%. I get extra 20% because I have 40% of both milk and dark, and then extra 20% of the milk. So this part's 40%, this part's 20%. And it tells me that, what do I have? There are 6 more milk chocolate candies. So I know the value of this area is 6 candies. So the value of each strip is 3 because 6 candies divided by 2 strips is 3. So that means every strip is worth 3. So this would be 3 candies, 3 candies, 3 candies, all of these. So 3 times 10 would be 30. Oops, I don't know why I wrote that. 30 candies. So that's one way to get that. Another way maybe would be to say, well, you know, then the difference is that 20% is 6 candies. Divide by 2 and get 10% is 3 candies. Scale it by dividing by 2. And then scale that by 10 to get that 100% would be 30 candies. So, I mean, you could do it that way as well. All right, let's look at number 22. And on 22, again, kind of like the Benton one, I think. It says, a dress is marked down 25%, then marked down 20 from the discounted price. All right, so again, I always like to use $100 just to play with it if you need to get a feel for it. So mark down 25%, which again is $25. That's why I purposely picked that. So now we're at $75. And then it's marked 20% down from that. Now, 20% is 10% twice. 10% is $7.50, so twice is $15, which makes it $60. Okay, so you could, the nice thing is since you picked 100 to 60, you can tell that you got 40% off. So 25 and 20 actually ended up making a 40% off. So by what percent was the dress marked down after both discounts? And the answer is it was marked down by 40%, okay? And again, what are you doing? If it's 25% off, you're paying 75% of the price. If it's another 20%, you're paying 80% of that amount. And on a calculator, if you take 0.8 times 0.75, that means you're paying 60% of it if you do the algebra there. And if you pay 60%, that means you're saving 40%. Because if you're paying 60%, right? If this is a 60% you're paying, what you're saving must be the rest. That must be your discount over there. Okay, 40%. Part B, does the dress cost the same, less, or more than if it was marked 45% from the start? Okay, well, you know, if you have a $100 item and if it was 45% off, you would have saved $45.55, right? So, you know, 40% is less, 45% would be you would have gotten more of a discount. Okay, this is a smaller discount. And then on part C, it says, if the dress were marked 20% first, then 25, would it be a different answer? Okay, so let's do it with $100 first. If we did the 20% first, again, that's $20, and that's strategic. But then 25% would be a fourth of this, which is $20, which is $60. So notice I get the same amount, okay? And why is that? Well, if I have the price and I do 80% first, and then I do 75, and again, 80% is what you're paying. If you have a 20% discount, you're paying 80%. If you have 25, you're paying 75. And again, I'm going to use the associative property and the commutative property here. So I'm going to group those. So 0.75 times 0.8. Again, notice you're paying 0.6 because we have the commutative property. So either way, the order doesn't matter. So I'm paying 60% of the price, which means I have a 40% discount. So the order there doesn't matter because the commutative property, you know, says that 0.75 times 0.8 is the same as 0.8 times 0.75. All right, hopefully the audio wasn't too bad. I'm sorry. The first time I made this video, there was no audio. So bad audio is better than no audio, in my opinion. So hopefully that helps. Take care.